Welcome to the course of analysis of several variable, and this is the part 2 of the module 2, and in this part 2 we are going to discuss about the norm of linear function. So let's start with the definitions of the norm of linear function. So suppose that a is a linear function from Rn to Rm, then the norm of a is defined as the supremum of absolute value of ax. And what kind of the x we will take it when x is belongs to Rn and absolute value of x is equal to 1. This is the other way we can express the definition. So here is mod x equal 1, which means that the component of x in Rn, so this component is square, like x1 square plus x2 square plus x3 square, so on, is equal 1. So to use this, we consider the first example is IDRN, which is the identity function from Rn to Rn, and the identity functions from Rn to Rn is given as IDRNx is equal x. So the norm of this identity matrix is defined as the norm of IDRN is equal supremum of IDRN as the definitions of the norm when x is absolute value of x is equal 1. Now as we see that here IDRN x equal x, so therefore this will be x and the mod of x is equal 1. So therefore if mod of x is equal 1, so this implies the supremum value will be 1. So therefore any identity matrix from identity functions from Rn to Rn, the norm is equal 1. Okay, let's have the norm of another function axy equal 2x plus 3y and 3x minus 2y. So in this case, we'll see that xy is from R2. So therefore, mod of x1 xy is equal to square root of x square plus y square, which should be equal to 1 as per the definitions of the norm. When we apply to the norm of a, then this should be equal 1. So the norm of a is given as supremum of axy, where xy belongs to R2 and absolute value of xy equal 1. So with this, we get it here that the definition supremum of, so ax is 2x minus 3y, 3x minus 2y, and this condition is as it is given. So now how to utilize this criteria and what is the absolute value of this one. So we know that absolute value of any component R1 and R2. So if it is from R2, then it will be the first component square plus second component square. So we have 2x plus 3y whole square plus 3x minus 2y whole square and the square root. Then we extend this and open the bracket, and we will say that this is equal 4x square plus 12xy plus 9y square, and this is 9x square minus 12xy plus 4y square. So minus 12xy and plus 12xy. So here is minus, here is plus. This will cancel out. So we'll have now 4 plus 9, 13, and here 9 plus 4, 13. So therefore, square root of 13x square plus 13y square. So take out the 13, you will get it. This is equal absolute value of norm xy. So now we already shown that absolute value of norm xy is equal 113.